You know, from your car to your wristwatch, there's this hidden magic that literally makes our world turn. We're talking about one of the most basic, most important inventions in all of engineering, the gear. And today, we're going to uncover its one big secret.
And honestly, it all boils down to this one simple question. It's a choice that every single machine with gears has to make. Do you want speed or do you want strength? Because here's the kicker. You can't have the maximum of both. It's one or the other. So how on earth does that work?
All right, so let's dive right in. Before we can even begin to understand this big trade-off, we gotta go back to square one and ask, what exactly is a gear anyway?
So on the surface, it seems pretty simple, right? It's just a wheel with some teeth on it. But oh, those teeth. They are absolutely the most important part. See, if you just push two smooth wheels together, they might slip. But with gears, the teeth lock in, they mesh, and that means zero slipping. The motion gets transferred perfectly every single time.
You know, here's a really great way to picture it. Think of gears as like friends holding hands. If one of them starts moving, the other one has to move along with them. No questions asked. That's exactly what those meshing teeth are doing. They're creating this perfect, totally predictable transfer of movement.
And it's right there, in that totally reliable transfer of motion, that the real magic happens, and where we finally get to that great trade-off.
Okay, so you've got two things in play here. On one side, you have speed, how fast something is spinning. And on the other, you've got strength, or what engineers call torque, which is basically the raw turning force. Now, here's the cool part. Gears let you swap one for the other. Want more speed? Fine, but you're going to have to give up some strength. Want more strength? No problem, but say goodbye to some of that speed. It's always a trade.
Okay, I know that might sound a little abstract, so let's make this whole idea a lot more, well, delicious. Just picture this. You've got a big bar of chocolate in front of you.
Now, you've got a choice to make here. You could take a bunch of tiny little bites really, really fast. That's your speed option. Or you could take one giant bite of the whole thing. But man, it's going to take you a while to chew through that. That's your strength option. The point is, you just can't eat a huge piece super duper fast. It's a trade-off. And believe it or not, gears work in the exact same way. So the big question is, how do gears actually make this trade happen? Well, the secret, it's not complicated at all. It really all just comes down to one super simple thing: size. Okay, there are just two basic rules you need to know. That's it. Rule number one, if a big gear turns a small gear, that little one is going to spin way faster, but it'll have less force. You're trading strength for speed. And rule number two is just the opposite. If a small gear turns a big gear, the big one will turn much slower, but with a whole lot more force. You're trading your speed for strength. Seriously, that's the entire secret. Let me give you a quick example just to make this super clear. Let's say you have a big gear with 40 teeth, and it's turning a little gear with only 10 teeth. Well, for every one time that big gear goes around, the little gear has to spin 4 times to keep up. It's 4 times faster. But, and you knew there was a but, right? This is the trade-off. It only has 1/4 of the turning strength. It's a perfect exchange. Because in physics, you just can't get something for nothing. And the amazing thing is, this isn't just some abstract theory. You, yes you, are making these exact trades between speed and strength all the time, and you probably don't even realize you're doing it. I mean, just think about riding a bicycle. When you're going up a steep hill, what do? You shift into an easy gear, right? What you're really doing is connecting a small gear at your pedals to a big gear on the wheel. Suddenly, pedaling is super easy. That's high strength, but you're moving pretty slowly. Then you get to a flat road. You shift to a hard gear, and now you're connecting your big pedal gear to a small wheel gear. Yeah, it's harder to push, but man, every single push gives you a ton of speed. You are literally actively choosing strength or speed with every shift. And you see this everywhere. Look at our wristwatch. It's all just tiny gears trading speed to make sure the second, minute, and hour hands all move at their own perfect, precise pace. Or think about your car. First gear. That is all about strength, pure muscle to get a heavy car moving from a complete stop. And fifth gear, that's the complete opposite. It's all about speed for just cruising efficiently down the highway. Okay, so if you're going to remember just one single thing from all of this, one golden rule that governs every gear system ever made, please make it this next part. Gears do not make power. They don't create energy out of thin air. Think about it. That gear on your bike doesn't magically make your legs stronger, does it? Nope. All it does is take the power you already have and transform it. It just converts it from speed into strength or from strength back into speed.
Honestly, the seesaw is the perfect way to picture this. You just can't have both sides up in the air at the same time, right? It's impossible. When one side goes up, let's call that speed. The other side has to go down, and we'll call that strength. When you boost your speed, your strength has to drop. It's because the total amount of energy in the system has to stay the same.
And that brings us to the ultimate cheat sheet. Seriously, this one slide pretty much sums up everything we've talked about. A big gear turning a small one, you get more speed, but you lose strength. Think, your car flying down the highway. A small gear turning a big one, you get more strength, but you lose speed. Think, you grinding up a huge hill on your bike.
So from now on, the next time you shift gears on your bike, or even just watch the hands of a clock, or hey, even use a simple can opener, you'll know exactly what's going on under the hood. You're not just turning a wheel, you're making that fundamental choice, speed or strength. Now that you know the rule, I promise, you are going to start seeing this trade-off absolutely everywhere.